Okay, my talk today is going to be on GraphQL. So here is an overview of what we will be discussing today. First, we'll dive into the history behind GraphQL and talk about why it was created. Then we'll go into what GraphQL actually is. And after that, I'll try to answer the question of should I use GraphQL by discussing the pros and cons. But first, before we dive into the history behind GraphQL, we need to talk about REST. So most applications today have the need to fetch data from a server where that data is stored in a database. It is the responsibility of the API to provide an interface to the stored data that fits an application's needs. REST is short for representational state transfer. It's an architectural style for building web services that interact via an HTTP protocol. REST principles were formulated in the year 2000 by the computer scientist Roy Fielding and gained much popularity as a scalable and flexible alternative to older methods of machine-to-machine communication. It still essentially remains the gold standard for public APIs. With a RESTful API, an application will make several requests to multiple endpoints in order to grab all the data needed for the application. Now here you can see a diagram showing a typical REST API in action. You can see here that the client requests the data from the server and the server responds back to the client with the requested resources. All right, the history of GraphQL and why it was created. In 2012, GraphQL was created by Facebook, now known as Meta. It was created as a new API standard that provides a more efficient, powerful, and flexible alternative to REST. Facebook started using GraphQL in 2012 in their native mobile apps, and they did this because there was a need for a more efficient way to fetch data through cell services. As you can imagine, data fetching through a cell service was and still is to some degree a serious issue when considering overfetching. Any data that you're fetching that isn't being used, you're paying for. In 2015, GraphQL was released as open source and publicly available. And it was created to fix this issue of overfetching along with many other issues, especially in regards to mobile phones. Surprisingly though, in recent years, GraphQL has mostly been picked up to be used in the context of web technologies and has gained only a little traction in the native mobile space. So why was it created? REST architecture is great and time proven to be the standard for most. So to answer the question as to why GraphQL was created, we should talk about some issues with REST. First major issue with REST is overfetching. As mentioned earlier, overfetching means that a client downloads more information than is actually required in the app. Imagine, for example, a screen that needs to display a list of users with only their names. In a REST API, this app would usually hit the user's endpoint, receive a JSON array with the user data, this response, however, might contain more information about the users that are returned, for example, their birthdays or addresses, information that is useless for the client because it only needs to display the user's names. You probably need data stored at multiple endpoints, thus every request that includes data you do not need is a waste to grab. Next, there's underfetching. Underfetching generally means that a specific endpoint doesn't provide enough of the required information. The client will have to make additional requests to fetch everything it needs. So let's actually talk about what it really is. Okay, GraphQL is arguably a more efficient alternative to REST. It is a query language for requesting and fetching data from APIs and a runtime for fulfilling queries. In order to best understand what GraphQL is, let's look at some diagrams and compare REST to GraphQL. All right, here's a diagram to better illustrate what multiple requests to many endpoints looks like when it comes to fetching data from an API with a RESTful architecture. Let's consider a simple example scenario. In a blogging application, an app needs to display the titles of the post of a specific user. The same screen also displays the names of the last 3 followers of that user. With a REST API, you would typically gather the data by accessing multiple endpoints. So in this example that we have here, these endpoints would be user's ID here to fetch the initial user data. Secondly, there's likely to be a user's ID posts here. Endpoints is going to return all the posts for the user, and the third endpoint will be the user's ID followers that will return a list of followers per user. In this case, with the REST API, you have to make 3 requests to different endpoints to fetch the required data. Because of this, you are overfetching, since the endpoints return additional information that's not needed. Here we go. This is a diagram of the same application using GraphQL. So in GraphQL, you'd simply send a single query to the GraphQL server that includes the concrete data requirements. The server then responds with a JSON object where these requirements are fulfilled. So here we can see there's this specific query, and we're reaching out to one specific endpoint, and GraphQL is returning back. And notice here the shape of the query and the shape of the response. So by using GraphQL, the client can specifically grab the exact data it needs in the query. And yeah, so let's go into a little bit more here. Let's talk about some additional reasons why GraphQL might be a more efficient alternative to REST. There has been an increased mobile usage around the world, which has created the need for efficient data loading. Increased mobile usage, low power devices, and sloppy networks were the initial reasons why Facebook developed GraphQL. GraphQL minimizes the amount of data that needs to be transferred over the network, and thus majorly improves applications operating under these conditions. Also today, there is a great variety of different front-end frameworks and platforms. The heterogeneous landscape of front-end frameworks and platforms that run client applications makes it difficult to build and maintain one API that would fit the requirements of all. With GraphQL, each client can access precisely the data it needs. Additionally, continuous deployment has become the standard for many companies. Rapid iteration and frequent product updates are indispensable. With REST APIs, the way data is exposed to the server often needs to be modified to account for the specific requirements and design changes on the client side. This hinders fast development practices and product iterations. A quick note: GraphQL is often confused with being a database technology. This is a misconception. GraphQL is a query language for APIs, not databases. So there's a rapidly growing community. Since GraphQL is a technology that can be used everywhere a client communicates with an API, it has quickly gained a large community that continues to grow. Today, GraphQL is used in production by lots of different companies such as GitHub, Twitter, Yelp, Shopify, and Pinterest, just to name a few. Interestingly, other companies like Netflix and Coursera were working on comparable ideas to make API interactions more efficient. Both of these companies have switched to using GraphQL. So, should we be using GraphQL? Let's talk about the pros and cons. So, kind of recapping what we mentioned before, this really big problem, there's no more over and under fetching. So overfetching again means the client downloads more information than is actually required in the application. Underfetching generally means that a specific endpoint doesn't provide enough of the required information. A client will have to make additional requests to fetch everything it needs. Next is the availability for rapid product iterations on the front end. A common pattern with REST APIs is to structure the endpoints according to the views that you have inside your app. This is handy because it allows for the client to get all the required information for a particular view by simply accessing the corresponding endpoint. Additionally, there are insightful analytics on the back end. GraphQL allows you to have fine-grained insights about the data that's requested on the back end. As each client specifies exactly what information it's interested in, it is possible to gain a deep understanding of how the available data is being used. This can, for example, help in evolving an API and deprecating specific fields that are not requested by any clients anymore. And lastly, we have the benefits of a schema and type system. GraphQL uses a strong type system to define the capabilities of an API. All the types that are exposed in an API are written down in a schema using the GraphQL schema definition language. And this schema serves as a contract between the client and the server to define how a client can access the data. Once the schema is defined, the teams working on the front end and back ends can do their work without further communication, since they both are aware of the definite structure of the data that's sent over the network. Front-end teams can easily test their applications by mocking the required data structures. Once the server is ready, the switch can be flipped for the client apps to load the data from the actual API. And now, some cons. Very steep learning curve. This is a big issue because it's incredibly complex to learn. Onboarding GraphQL into an existing project is really difficult. Queries can be much more complex with a REST API. So when we have to access multiple fields in one query, whether it is requested in a RESTful architecture or GraphQL, the varied resources and fields still have to be retrieved from a data source. So it shows the same problems when a client requests too many nested fields data at a single time. So there must be a mechanism like maximum query depths, query complexity weighing, avoiding recursion, or persistent queries to stop inefficient requests from the client side. There are issues with error reporting. It's not super straightforward on how to handle certain error cases with GraphQL right out of the box. May not be as good at caching compared to traditional REST. It is more complicated to implement a simplified cache with GraphQL than implementing it in REST. In a REST API, we access resources with URLs, so we can cache on a resource level because we have the resource URL as an identifier. On the other hand, in GraphQL, it is very complex because each query can be different, even though it operates the same entity, on the same entity. But most libraries built on top of GraphQL offer an efficient caching mechanism. And lastly, it may lack performance comparatively. And here we are. These are my resources. And thanks everyone for attending my tech talk.
All right. Thank you, Avi. If everybody could unmute and give Avi another round of applause.
Woo, woo.
Good job, Avi.
Good job, Avi. Great. Amazing. Awesome. Cool. So I do want to open the floor for some questions. Due to time, though, we do only have room for one question. Max, what you got?
Hey, Avi, great talk. I heard you mention that GraphQL is not related to databases. I'm curious why the developers of GraphQL decided to use the word graph in their technology. Is there a reason they decided to name it this?
Yeah, great question, Max. Thanks for asking. So yes, as mentioned before, it is correct that GraphQL is not related to graph databases. The reason for calling GraphQL this name, which includes the word graph, is because it does something it does use something called the application data graph. So this is essentially a graph-like data structure that GraphQL creates from the backend data received. And GraphQL will then traverse the application data graph and extract out the specific trees needed. This is what allows GraphQL to have such flexible querying. Hopefully that's helpful.
Awesome, thank you.
Awesome. Well then, if that's all the questions, then this concludes our tech talk for this evening. Thank you all so much.